Hi guys, this video we're going to be focusing on circle geometry. Basically next year, as part of your geometric reasoning topic, you will learn a whole lot of angle rules specifically about the insides of circles, and to be honest can get quite complicated. So I thought we'd just do a bit of an introduction to that today and just give you a bit of a head start there. We're just going to focus on two different rules today, and then I've got a bit of work that you can do in class to practice it. My maths task wasn't overly appropriate because it gave you a bit too much at once, and I just wanted it to be a bit of a easy way into it, I guess. So to get started, we've got a circle. I'm going to draw two radius or two radii. Now, because it's a radius, they're both going to be the same length. Now, if I join the two radii to make a triangle, then that triangle is always going to be an isosceles triangle, because that line and that line are always going to be the same. Okay, so there's an angle geometry rule that goes with that, and the shorthand that we get for these rules is a little bit more complicated than what we saw with the other rules that we've learnt, but it's definitely easier to learn it this way rather than trying to write it all out in full. So this is what we're going to do. Now, what we've got here is an isosceles triangle, and we know it's an isosceles triangle because we've got two equal radii, and if we wanted to, we look at those two angles, we would say that angle X is the same as angle Y because base angles of an isosceles triangle are equal. Okay, so we're kind of explaining that in three ways. We're saying, first of all, it's an isosceles triangle because we've got these two equal radii, and then because it's an isosceles triangle, angle X is the same as angle Y. So what we would say is X equals Y, and our reason would say it's isosceles triangle, equal radii, base angles are equal. Sorry, that kind of ran out of room there, but that's alright. Say that again, isosceles triangle, equal radii, base angles are equal. Okay, and that's how we can describe that geometrically. I've got two examples prepared for you, so we'll work our way through these. This first one is very similar to what we see up here. We've got an angle marked X, we've got an angle marked 21 degrees, and we can use this exact argument here. Okay, so we would say that X is equal to 21 degrees, and our reason, it's an isosceles triangle. We know it's isosceles because of the two equal radii, and because it's an isosceles triangle, base angles are equal. Okay. Now, second example, it's the same sort of philosophy, but again we are going to have to do it slightly different because this time we're given 68 here, we're not given Y, and that's what we have to find out. So what we can say is it's an isosceles triangle because it has two equal radii, so that's the same, but this time we're using the fact that angles in a triangle add to 180 degrees as well as the isosceles triangle thing. So angles in triangle add to 180 degrees. Okay, so that would be our reason. So the way we would work it out is we would say 180 minus 68, which would give us the two base angles, and then we'd divide that by 2. So that's the calculation we'd do, which I'd expect you to be able to do, but the justification is quite important. So to work it out, as I said, 180 take away 68, which is 112, divide that by 2, and that equals 56. Now you'll see that my working is not overly concerned about the calculations. It's more about the reasoning behind it, and that's what is really important. So that's the focus of this topic. Okay, so you can rely on your calculators to do your calculations. You don't need to write a whole lot of working. You do have to write your reasons. Okay, so that is the first triangle rule I was going to go through with you. Now we'll have a look at the second one. I prepared some triangles just to speed things up a little bit. So this one is about tangents to a circle. Now hopefully we know that a tangent is a line that just touches the circumference of a circle. Okay, and we're going to look at two rules, I guess, associated with tangents. So if we just head that up as tangents. Now our first rule, if we look at it, we've got a radius intersecting or meeting a tangent. That angle that it makes, so if we think about this angle here, angle OTB, it is always 90 degrees. Anytime a radius meets a tangent, that angle will always be 90 degrees. Okay, and the rule for that is actually quite simple. Tangent, TGT, perpendicular, that's the symbol for perpendicular, which means 90 degrees, and rad, short for radius. Okay, so this one's nice and simple. Tangent, perpendicular to radius. And you can make the same argument for this angle on this side. Angle ATO is equal to 90 degrees because the tangent is perpendicular to the radius. Same reason. So that's our first rule with tangents. Second rule is where we have two tangents that are both made from a point outside the circle. Okay, so if we look here, we've got this point here which I've labelled T, and this point is outside the circle, and from here we've gone one in each direction where we're just touching this triangle at points A and point B, so not just touching the circle. And also inside the circle I've drawn lines from the origin or from the centre of the circle to A and from the centre of the circle to B. So the lines OA and OB are to radius. And then, just to keep it interesting, we've joined the points A and B to make a triangle OAB, and that at the same time has made a triangle OTB. So quite a lot going on in here. Let's see if we can nut it all out. So if we'll start by looking at the triangle ABT. One of the best pieces of advice I can give you about this angle geometry stuff is you need to learn to ignore the irrelevant information. So basically we're just looking at that to start with. We're ignoring the top, we're just looking at this bottom part, OBT, get the wording right, and what we get is an isosceles triangle. And the reason it's an isosceles triangle is because they're two equal tangents, and that is a rule. Okay, so we can say AT is equal to BT, and the reason for that is equal tangents. So that means that ABT is an isosceles triangle. And because it's an isosceles triangle, we now have enough information to work out the angle X. Because we've got a 62 degrees here, so X is going to be 180 minus 62 divided by 2. So we can say X equals 59 degrees. Base angles isosceles triangle are equal. Okay, so we've started off by proving why it's an isosceles triangle, and that's with this rule that come from two equal tangents. And then, because we know it's isosceles, we've then said that angle X is 59 degrees. And last of all, we want to work out angle Y, and we can see that OA is similar to this situation up here, where we've got a radius perpendicular to a tangent, and that's exactly what we've got here. Okay, so this angle xy, or x plus y, is going to be 90 degrees. So we can say y is 31 degrees, which is 90 minus 59, and our reason is this reason up here. Tangent perpendicular to radius. Now that is the end of this lesson, and I do understand that it's going to be confusing, so not expecting everyone to get it first time, and I am expecting questions from you when I see you in class, but good idea to maybe have another look at it and have another look at the way I've explained it, and I'll be expecting to see you in class with plenty of questions, because as I said, there's no homework task matching this video, and we will be getting on with it in class.